Hi everyone, welcome back to another video of our Ethereum series. In this video, we'll take a look into the various components that make up the Ethereum network. So, Ethereum is a blockchain with a computer embedded in it. This is different from Bitcoin. Bitcoin is a simple blockchain where you keep a record of all the transactions. Ethereum also has a stack machine built into it, so you can push some code onto the Ethereum network and then you can call functions to execute that code on the network, and the EVM part of Ethereum, it executes that code. So that is the embedded computer part of Ethereum. Now this also makes it a very good foundation for building apps and organizations in a decentralized, permissionless and censorship resistant way. One term that you'll see a lot thrown around is Ethereum 2.0. So Ethereum 2.0 is not really a new blockchain. It is the Ethereum network only. It's just that Ethereum network is in a transition phase where multiple upgrades are being applied to the network to improve its performance and efficiency. And all of these upgrades would be applied to the network over a period of 2-3 years. And all of these interconnected upgrades are collectively called Ethereum 2.0. One of the primary goals of Ethereum 2.0 is to improve the scalability aspect of Ethereum, allowing it to handle more transactions per second, hence increasing the performance. So there's a particular section called Ethereum Roadmap in the Ethereum documentation. You can check it out on this URL, or you can simply do a Google search of Ethereum Roadmap and you'll end up here. This is a very good page which highlights a lot of things about the Ethereum 2.0 and all of the upgrades that are planned. So you'll see a list of all of those upgrades here and what they're all about. So it's a very good read. I would highly recommend you take time and just skim through it so that you have a better understanding of what this is all about. Okay, so now we'll discuss the components of Ethereum one by one. The first one is Ether. Ether is a native cryptocurrency needed to use the network and pay the miners and validators, that is, the nodes of the network. The purpose behind Ether is to allow for a market for computation. So, I have created a very simple diagram which showcases the Ethereum network in a nutshell, and I'll refer to it time and time again to explain the concepts better. Now, this specific line that the purpose of Ether is to allow for a market for computation. Let's understand that in detail. So, Ethereum is a network that is being run by various nodes. All of these nodes are contributing their computational power to the network, which means anybody who is using the network, they'll end up doing some kind of computation on the network. If a user makes a transaction, it would change the state of the Ethereum network, that is the EVM. So some computation would be required to carry it out, and that computation would be provided by the node. So in order to incentivize these nodes to keep running the network, you have to introduce a mechanism that compensates them for providing their resources to the network. That's where Ether comes into play. That whenever a user puts a transaction or does some kind of activity on the network, they have to pay the nodes using Ether in proportion to the amount of computation that they are doing. So that's how Ether acts as an incentive design, providing an economic incentive for the participants, that is, the nodes running the network, to verify and execute the transaction request and provide computational resources to the network. Next is EVM, also known as Ethereum Virtual Machine. So, Ethereum Virtual Machine is a single canonical computer with a distributed state. Every node in the Ethereum network agrees on and keeps a copy of that state. So you can see that the entire Ethereum network is divided into two parts. One is EVM, the other is the network. If you recall from a previous video about blockchains, a network of nodes maintain a collective state of the blockchain. Here, that state is EVM. This contains all of the accounts and their balances and the smart contract. And it also has a stack machine built into it. So, whenever you have to execute some code, it executes that. Now, any participant can broadcast a request for EVM to perform any computation. This could be anything. For example, if you want to swap a token on Uniswap, you simply initiate a transaction that swap my 100 USDC for an equivalent amount of Ether. and Uniswap smart contract will do that for you. Under the hood, it is in fact the EVM that is executing all of that code and carrying out your transaction. So, whenever you initiate such a transaction request, it is broadcasted on the entire network. It is then verified, validated, and the computation is carried out. This computation results in a state change of the EVM. Like earlier, you had 100 USDC in your account balance. Now you don't have. You have an equivalent amount of Ethereum in your account. So the state of EVM is changed now. So this change is committed and propagated throughout the entire network, and each node of the Ethereum network keeps a copy of this new state. Next is smart contract. Smart contract is a reusable snippet of code put on the EVM by a developer. So this could be anything like a game marketplace or a financial instrument like a DeFi application. And it is usually written using Solidity, Viper, or an assembly language. So any user can request the smart contract code to be executed by making a transaction request. And I have already taken an example like Uniswap. When you want to swap your tokens for another token, you basically make a transaction request on the smart contract of Uniswap that swap my X tokens for Y token. Next is accounts. Accounts are where Ether is stored. User can initialize accounts, deposit Ether into their accounts, and transfer Ether from their accounts to other users. This is also applicable for tokens. Like you can own certain NFTs on blockchain. You can transfer it to other people, and you can also own some other ERC20 tokens. So you keep all of those things in your account, and the accounts and the account balances, as in the amount of Ether and the tokens you have, are all a part of the overall EVM state. Then we have transactions. A transaction request is the formal term for whenever you ask a smart contract to do some kind of code execution, again, like swapping tokens on Uniswap. Once that change is carried out successfully and is committed to the blockchain, it becomes a transaction. So, as a user, you can broadcast a transaction request to the network from any node. And for the transaction request to actually carry out a change on the EVM state, it is first validated, executed, and committed to the network by some other node, and then this execution of code carries out a change in the EVM, which is then stored by all of the nodes in the network. So, again, if we go back to our diagram here, in the EVM state, we have our account and we also have smart contracts. So, smart contracts are in a way special accounts that also hold an executable code within them. And whenever you make a transaction request, let's say you are calling Uniswap to swap some tokens, you are basically creating a transaction request on the Ethereum network, and you'll send in some Ether along with it. And then the state of EVM would be changed. Like you had 100 USDC earlier, and now you have an equivalent amount of Ethereum in your account, and that would be done by the Uniswap smart contract. So this entire change is carried out by a node and then propagated throughout the network and then added to the blockchain. Next is blocks. So since the volume of transactions is very high, all of these transactions are batched together and committed on the blockchain. So a single block may generally contain between dozens to hundreds of transactions. Now, whenever you make a transaction request on the network, it is carrying out some computation and the node is doing that work for you. How do you measure that how much computation is being done, because different kind of applications would do different amount of computation? So gas is something that helps there. Gas is simply a unit that measures the amount of computational effort required to execute some specific operations on the Ethereum network. It is similar to a fuel that allows it to operate in the same way that a car needs gasoline or battery to run. Then we have nodes, the entities that are actually running and maintaining the networks. These are real life machines which are storing the EVM state, and they communicate with each other to propagate information about the EVM state and whenever the EVM state changes. And any user can create a transaction request and broadcast it from any node. The Ethereum network, you can say, in itself is an aggregate of all of the Ethereum nodes and their communication, because they are the ones who are keeping a copy of the EVM state among themselves, changing it, updating the EVM state, and then arriving at a consensus that what the next EVM state would be. Now, all of these nodes collectively form a network. Ethereum network is nothing but a group of connected computers that communicate using the Ethereum protocol. Each node has a client running on them. It could be a Geth client or Parity client, but all of them define the specifications of the Ethereum protocol, how it should be run. And each node is running a client. Using that, they communicate together to maintain the EVM state. There's only one Ethereum mainnet, but some other networks can also be created for testing and development purposes, like we have Gurley and Sepolia. So these are just a different set of nodes running Ethereum protocol for a different purpose altogether. We can also have private Ethereum network, as in the case with some enterprise use cases. In the last, we have consensus mechanism. Consensus mechanism, if you recall from our Water blockchain's video, consensus mechanism is an algorithm that is used by all of these nodes to arrive at a consensus that what should be the state of the blockchain or the state of the EVM in the case of Ethereum network. So the consensus mechanism is an entire stack of protocols, incentives, and ideas that allows the network of nodes to agree on the state of a blockchain. Ethereum earlier used the proof of work mechanism, but now has transitioned to proof of stake. So, to summarize all of that we have covered, we have an Ethereum network which mainly has two parts. One is EVM, and the other is network of nodes maintaining that EVM state. This EVM state contains all of the accounts and the balances. Some special accounts also contain a code with them that can be executed, and these are called smart contracts. A user can create a transaction request on the network which would do some kind of computation. They are essentially calling a function of the smart contract, and some changes brought about in the EVM, like earlier account balance was 10, now it's 20. The transaction that carries out the state change is executed on the EVM, and then it is propagated among all of the nodes of the network, and together they validate and verify that transaction. Once it's approved, it is added to the blockchain and you have a new EVM state. In exchange for providing resources for maintaining and updating the Ethereum network by carrying out the computations requested by the user, Ether is used as an incentive mechanism where the user pays the nodes in proportion to the amount of computation that they are requesting. This computation is measured in terms of gas. So that was a high level overview of the Ethereum network. Now we'll discuss each of these components in detail one by one.